Hey Kevin, great to see you. Thanks for your time today. How are you doing?
Oh, I'm doing great. It's a beautiful sunny day here in Denver, Colorado. How are you?
Doing well. I'm doing well, thanks. I appreciate you making some time for me today. What I want to talk about a little bit today is how we leverage data science at Cognidops. I'm talking to some of our clients and different companies every day, and they're very interested in how it works and what value can they get from using data science. And I thought you could help us bring a little clarity to the subject. Every morning I open the Wall Street Journal, Business Week, and there's new articles about how artificial intelligence is going to transform supply chain. We're going to get intelligent fulfillment, and our distribution centers are going to become more flexible and resilient. It certainly sounds like there is a great promise, and I just really want to understand what's real and what's behind it. But before we get into that, why don't we start by having you introduce yourself? Tell us a little bit about your background.
Yeah, sure thing. So my name is Kevin. I've been here at Cognitops for about 2 years now, leading our data science team, as we've built out what I think is a really remarkable machine learning system. After going to grad school for statistical physics many years ago, I was looking for some ways that I could apply math and science and programming to real world problems instead of working on these really abstracted problems, very theoretical kinds of things that we were doing in the lab back there. And I spent about a decade working in and leading different analytics startups, where I mostly specialized in things like e-commerce analytics and marketing, like hyper-targeted ads on social media and that sort of thing. But when I met Reese and Alex, the co-founders here at Cognitops, I recognized immediately they were onto something really special. So for the last couple of years, I've had the pleasure of working on some of the most interesting and really actionable data science projects that I've seen in my career.
Okay, well, great. That's awesome. Thank you. Thank you for that background. It's been great to meet you and get to work with you this past year.
Likewise.
Um, every day I read a new definition about what artificial intelligence is and a new buzzword, whether it's machine learning, digital twin, big data. But, based on all of the different usages and all of the excitement around it, the words are really losing any relevant meaning. And I was wondering if you could break this down into some more tangible chunks and how you think about these different categories of data science at Cognitops.
Oh, absolutely. It's almost like people are trying to be intentionally confusing here. Uh,
Hmm.
but I think that it's really there's some real concrete value that can come out of these tools, and we can try to break down how that works for us here at Cognitops and how it, like you said, can bring value and really a transformative approach to problems in a distribution center. Probably you've heard about AI or machine learning in the context of robotics or machine vision. But here at Cognitops, we're taking a wholly different approach than that,
Hmm.
where machine learning and artificial intelligence really shine is in making sense of the complex interrelationships between things, or in automating error prone, tedious, and detailed tasks that humans either, can't do at a large volume or would make lots of little mistakes at along the way. As humans, we can only keep a limited amount of information in our head at any given time. It's hard for us to see the whole picture all at once of a very complicated system. And in a distribution center, there are hundreds or thousands of simultaneous factors that drive flow, that can create bottlenecks or drive up costs. And they're also changing minute by minute. This is where our digital twin comes into play because we can take a snapshot of a distribution center at a moment in time. And then with that snapshot, we know what orders are in progress or where inventory is low or where workers are logged in, that kind of thing. And then by taking many snapshots throughout the day, the digital twin turns that raw distribution center data into many different complex time series data sets. So it's just like how a film is a sequence of images strung together to create motion. We take a sequence of images of everything that's happening in the distribution center and create that film of how the day plays out. So we securely store this data forever, and that gives us an understanding of the minute by minute evolution of every component of the building. And now, with all of that data available, much more than a person can kind of digest and think about as an individual, we build these artificial intelligence models that predict how any of those will change and evolve over time. Whereas a human has a hard time understanding and just observing all of that information all at once, machine learning models can ingest millions of data points with no problem and then make predictions based on those.
So because you have this film of the snapshots that you created, you have the ability to start to predict how things will evolve into the future?
Yeah, that's exactly right. And that's where the machine learning piece comes in, right? That's the forecasting, that's the prediction. It sees the patterns, how they change over time. It sees patterns that a human can't identify very quickly. It sees those things happen dynamically and in real time, and then can make predictions into how each of those can change over time. So for example, we track orders as they come in real time. And because we have that film of the order history and everything else that's happening in the building, our models can forecast orders before they arrive. Or we could predict how much time it would take to complete a given task based on the characteristics of that job, that sort of thing.
Okay.
And then the real power of these models is that they're continuously updating. So our MLOps architecture, it retrains all of our models constantly as they observe new patterns in the building. They're continuously relearning how to make these predictions. And so that means
you're not just creating one forecast and then letting that go for the rest of the day or for the rest of the week.
Yeah, that's exactly right. They're in real time observing what's happening and changing the kinds of predictions they make based on what they observe. So it means they're immediately adaptive to changes without human intervention. And then lastly, we're rethinking what simulation means for supply chain. So for us, we're not talking about the agent-based models where you see little cartoons of guys walking around a picture that looks like your building. Instead, we build our simulations on top of these adaptive ML models, which means the simulations themselves automatically adapt to real-time changes. The adaptive simulations let us, kind of model out countless possible futures, different ways that the building could evolve throughout a day or throughout a shift. And then we identify a set of decisions that operators can make throughout that day that would have the largest possible impact on things like throughput or cost, finding those few leverage points that have the biggest impact on the system overall. And, we're talking about decisions like when to release a wave or changing batch size or moving labor around.
Okay.
And because the simulations are powered by those predictive capabilities, they let you respond to problems or changes before those changes even happen.
Wow. That sounds like it could be really powerful for some of these DC operators. It's going to allow them to move from being a reactive manager to seeing what happens and adjusting to it, to being proactive, to addressing change before it even happens, which is incredible.
That's exactly
it sounds like it's not just, so it sounds like data science, where we've heard about it from an artificial intelligence perspective. It's not just all about vision and robotics. There are other areas where we can apply it here.
Yeah, that's right. We're really thinking about this as a decision science.
Okay. Well, that's fantastic. I mean, given the speed and the complexity of some of the modern DCs, the omni-channel, the e-commerce, the high-speed industrial DCs, the ability to automate that decision making and make decision making smarter and more adaptive is going to be incredibly valuable in the DCs of the future. So let's dig into some of those examples a little bit more. In what ways have you seen some of our CogniTops clients been able to start using AI to help improve their operations or automate their decision making?
Yeah, it's a great question. I mentioned forecasting orders a moment ago, so let's dig into that a little bit more.
All right.
Uh, if you think about it, how many of an operator's decisions hang on the content and the profile of the order pool at any given time? It influences so much of what's happening in the building. What our order forecaster does is it gives the operator essentially a crystal ball. CogniTops users can see if, for example, they're about to get slammed with an unusually high volume of single unit orders or hazmat or VAS, or if they need to go replan some SKU before a flood of orders comes down the pipe. This is more important today than it's ever been because operators are walking this tightrope between maintaining social distance, safety protocols, but also meeting increased, unprecedented, often hard to predict demand. By understanding how the order profile will shift and fluctuate throughout the course of a shift or a day, operators can make these informed decisions about labor balancing so they can maintain a nice, steady flow through the building. Or they can check in at the start of the day and see what equipment they need to have staffed. For example, how many, put walls should be active. And they can also head off bottlenecks before they happen because they won't get caught with their pants down when, the putters are outpacing the pickers and batches all start piling up and pick. The ML-powered simulations that we run are able to see that thing coming from a mile away.
Okay, fantastic. So this is a really powerful way for them to think about how do I balance flow and balance labor and predict when exceptions are going to occur and address them in advance. So really becoming responsive and proactive managers of their complex buildings.
That's right, and all doing that as efficiently and cost effectively as possible.
Wow, I mean, this sounds fantastic, but the thing I think that I'm challenged with, Kevin, is this sounds like it's really hard to enable. Like it sounds like getting my legacy WMS or my control system that have been in place for 20 plus years. They've been highly customized and they're not built to be, cloud enabled. They're not built to be easy to connect to. We've customized them with all of our business logic from decades of operating. How can I leverage data science when this is the kind of data that I have? Because it sounds like you need lots and lots of features and data points to power your artificial intelligence algorithms.
Yeah, the real truth is you probably have a lot more than you think you do. I read an industry report just last year that said something like machine learning for the fulfillment center was still a decade away because current to systems just don't have the data sufficient to support data science. But that's honestly, that's ridiculous. That's baloney. The truth is, if machine learning couldn't work with real world messy data, then I'd be out of a job. And really the whole field of data science wouldn't exist.
Right.
At CogniTops, we've designed our system with the fulfillment center in mind. And it works specifically with just the most elementary data that a distribution center has available. Things like orders, lines, maybe SKU master, maybe some labor data, and that's it. Our digital twin then takes that simple data feed and it builds a complex data asset out of it, from taking those slices and putting them together and creating all those time series, that film of how the
it's really the connection from one snapshot to another, and looking at the change between the snapshots that you're starting to look at.
That's right. And we keep all of that forever. We never delete data, we never archive it. So we have the full history, minute by minute, how everything has changed over time. And suddenly we now have this rich, complex data set built off of very simple data feeds and snapshots. So if you want to know, I don't know, how many lines were picked from a particular location 9 Wednesdays ago, we have that. We can tell you. And our models are adaptive, right? They're kind of like a goat. They'll eat anything you feed them, and they're stubborn. They're working all day long, continuously. They're never giving up. So we can get started delivering useful forecasts with minimal data integration. And operators get access to more visibility and insight than they've had before, starting right away. But because the system improves every day, the value we deliver, it just snowballs. Day after day, our system learns a little bit more, a little bit more, a little bit more about how to operate, how to optimize your specific operation.
Okay. So if I was to summarize that, data science was really built to support dirty data. And if you have complex bad data, data science might be the only way for you to generate powerful analytics and guide your operations, because hard coding some kind of model is just going to be very, very difficult to do. And you're
how are you supposed to deal with, minutes and days and weeks and months of each of these individual units of data in an Excel spreadsheet, in your own personal notes and sticky notes, and keep it in your mind? You can't do that. You need the support of something like data science, machine learning, these kinds of algorithms to be able to parse and interpret that information for you.
Got it. And so you're generating the data you need based on simple data, but you're creating feature-rich data by frequently looking at simple data feeds and looking at the change across that data. So that's really how you understand when different processes change, or performance of the building changes over time.
Yeah, that's right. And we don't need any kind of human intervention to notice those changes. So if you undertake a reslotting exercise, we'll be able to notice the difference in where orders are picked from, and we'll be able to notice the different time it takes to complete certain kinds of jobs or work through certain kinds of batches. We don't need to send in consultants to go remap out your building to be able to reconfigure a heavyweight simulation. All of that adapts automatically.
Great. Okay. Well, sounds fantastic. Well, let's just close on this, Kevin. Tell me a little bit about where you're going in 2021. What is going to be the focus for you and your data science team at Cognitops?
Oh, I'm so excited. What we're really doing is we're creating the collective memory of the warehouse. And we're building out playbooks for any conceivable scenario an operator might encounter. We're taking the intuition of the best operators on the planet, and we're turning that into a true science. And we're just going to continue to drive innovative practices that improve the efficiency and productivity of fulfillment centers. It's really all we think about.
Awesome. Cool, man. Well, thank you very much for your time. That was really, really helpful. For everybody who listened and made it this far in, please reach out to Kevin or I if you have any questions. Contact info is here. The emails are simple. Look forward to hearing from you. And Kevin, we'll have to do this again soon. Thanks, man.
Thanks, Roger. I had a blast.
Okay.